All right, so I think this is recording. Let's take a look here at problem number 3. We have a third degree polynomial function. So we don't have any X method or any type of way that we can really factor this. Sometimes you can factor by grouping, but not all the time. The leading coefficient is 2, which is positive. So it's going up to the right, down to the left. The y-intercept, if you input 0 into this function, you get 20, which has coordinates 0, 20. I notice that all of these are even numbers, so I can factor out a 2. And we'll want to do that because the list that we generate uses the constant term and the leading coefficient. So the factors of 10 being plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. If you didn't notice that this greatest common factor was 2, you're going to have a much longer list, and it's possible that it could take you a little bit longer to go through that list to find the zeros of the function. So let's, if we set this equal to 0, you can see that 2 is not going to cause, 2 will not cause this product to be 0. So if you divide both sides by 2, 2 does not come into consideration when we're trying to find these zeros. Let's go ahead and plug in 1 and see what we have. So rather than call it P of X, I'm going to call it R of X for like a reduced polynomial. So if I plug in 1, what do I have? 1 minus 2 minus 5 plus 10, and that's not equal to 0. What if I try a negative 1? Negative 1 minus 2 plus 5 plus 10, and that's not equal to 0. What if we try a 2? 2 cubed is 8, minus 2 times 2 squared is also 8. Minus 10 plus 10, and there we have our 0. So let's do synthetic division on this with 2. And I'm going to do synthetic division on the factored form. So I've got 1, negative 2, negative 5, 10. I'm fully expecting this to be a 0 over here, or I've made a mistake down here somewhere. And I do get a 0, so that means that this polynomial function factors to x minus 2, and this is 1x, this says 0 x's, so x squared minus 5. We already said that 2 didn't have any, 2 didn't come into play at all with getting this product to be 0, so either x equals 2, if x squared is equal to 5, then that means that x is equal to plus or minus the square root of 5. I don't think I would need that, but I don't want to delete it in case I do. All right. So my table that has my zeros, my multiplicity, and how it intersects the x-axis. Now, although I didn't factor it here, this x squared minus 5, we want to think of it as x plus the square root of 5 times x minus the square root of 5. And that helps us to see that the multiplicity there is 1. So all of these are across. All right, well, I hope that helps, and I'll talk to you later. Bye.